Okay, so we're talking about properties of exponents. Let's talk about the product property. That means when you multiply things like this, it's really simple. 3 to the fourth times 3 to the third would be 3 to the, do you know? Seventh. And if you don't understand why that is, let me show you why that is. Looking at this one, 2 to the third, that means 2 times 2 times 2, right? Isn't that what 2 to the third means? And then 2 to the fourth is, I'll do that in green, 2 times 2 times 2 times 2. And this is a times problem, so I can put a times in between them. And notice a big stretch of 2's that are all being multiplied. It's 2 to the, count them up, 7. So if you just notice that it's just add these two, you're right. Any questions on that? All right, so then answer that question. What is it? X to the 11th, that's all there is to it. All right, but there are a lot of little rules. You got to know this one too. It's quotient when you divide them. And what it means is, if I have 2 to the 5th, that means this. 5 2's all multiplied. 2 to the 2nd means 2 2's. And then, these cancel, doink, doink, it would be 2 to the 3rd. How could I have done that even faster? Just subtract them. The 5 minus the 2 makes to the 3rd. So if I was going to do a to the m, you aren't talking about math. Focus. A to the m over a to the n, it would be a to the, what? M minus n. All right, that's the more algebraic way to do it. All right, this one would be 4 to the, what? 3rd. So that's pretty easy. All right, go to the next slide. What is this one? X to the what? 12 minus 9 is? All right, x to the 3rd. On to the next one. A to the negative n. That means it's a to the n, except you flip it. So it's 1 over a to the n. What I mean is, down here, 2 to the negative 1. Wouldn't you agree that's the same as 2 to the 1, except a little bit different? Okay, so what's 2 to the 1? No, 2 to the 1. 2 to the first power is what? 2. And then you put 1 over that. So the answer is 1 over 2. So you act like you do the problem without the negative. So it's just 2 to the 1. 2. And then you remember, oh, that's right, it was a negative exponent. 1 over whatever you were going to have. All right, so this one. Act like it was 2 squared, which is what? 4. But then you remember that there was actually negative, and so it's 1 over 4. You getting that? All right, next one. 3 to the 3rd, 27, and so 1 over 27. All right, good. So 6 to the negative 1 is 1/6. Because 6 to the 1 would be 6, but then you put 1 over it. All right, moving on. This one, a to the 0, anything to the 0 is 1. And I know you probably have that one memorized, but I want to make sure you understand why it's true. Because, everybody add a blank page. Add a blank page. Put your iPad down so I can see what's on your screen, please. Yeah, that's what I thought. Get into the notes for today. Rapido, por favor. All right, and you've added a blank page in there, and here's why. I'd like you to write this series. 8, underneath it 4, underneath it 2, underneath it 1. Now, can you see what I just did there? I cut it in half every time, right? Now, what I want you to think of is, this would be 2 to the first power, wouldn't it? This would be 2 to the second, this would be 2 to the third, and then what is that one underneath it then? 2 to the 0. Do you get how it has to be 1 to follow the pattern? And then if you add 2 to the negative first power, remember it's half of each time. Half of 8 is 4, half of 4 is 2, half of 2 is 1. What's half of 1? And that's what the right answer is. See how that makes sense? All right, so how about 2 to the negative 2? Well, that'd be like 2 squared is 4, and then you put 1 over it, 1 over 4. And is it half of 1/2? Yeah, well, half of a half is a fourth. So it works. That's why. Now, somebody said, well, but then how about 3? Because 3 will be totally different. Well, it is different, but it still works. What's 3 to the 1? 3. What's 3 to the second? What's 3 to the third? 27. You should have that one memorized. And now, what's happening here each time when I go down? I'm going down to 1/3 of what it used to be. 1/3 of what it used to be. What's 1/3 of 3? 1. So 3 to the 0 power, which is what I think he was talking about, equals 1. And then 3 to the negative 1 would be 1/3 of this, right? Which is 1/3. And that's the same as if I had done 3 to the 1 power and then flipped it. All right. Let's move on. Power of a power. So get on this slide. All right. 3 to the second to the fourth means this. 3 to the second times itself 4 times. Do you have to write this out? No. I'm just trying to show you why the answer is, well, what does 3 to the second mean? 9. So it's really 9 times 9 times 9 times 9. Another way to think of it is that this is 3 to the that plus that plus that plus that. 3 to the 8th. Wouldn't it have been faster to just multiply these two? Yes. But I'm just showing you why you multiply those two. So then this is really x to the, multiply these two. What? 20th. And this would be h to the 30th. Good. You just need to know these rules really well for what we're doing today. All right, so this is b to the 27th. Good. All right, moving on. Power of a product. Here's the question. Do you take 5 squared times 4 squared, or do you do 5 times 4 and then square it? All right, let's see if they come out different. 5 times 4 is 20, and 20 squared is 400. If I had done 5 squared and 4 squared, it'd be 25 times 16, and guess what? Ends up being 400. The moral of the story is you can either multiply them first and then square it, or you can take each one of them squared. So like 3 to the third and 2 to the third. So I could do 3 to the third is 27 times 2 to the third, which is 8. 27 times 8 will give me my answer, but it'd probably be the same exact thing as if I had did 3 times 2 is 6 to the third. And 6 to the third means 6 times 6 is 36, and 36 times 6. 216, I think, actually. And let's see if 27 times 8 is actually 216. 7 times 8 is 56. 16 plus 5 is 216. So yeah, either way works. Why do I need to know that? Because if it's 2a to the third, you can't do 2 times a and then cube it. Can you? But you can do 2 to the third and then a to the third and get 8a to the third. Do you get what I'm saying? All right, so you need to be able to know how to split that one up. All right, that's a lot different than, here's the one that everybody makes a mistake on then. They think, oh, well, so I can just do 2 squared and a squared. The one I just did before was a multiply. This is an add. This one means 2 plus a times 2 plus a, and you'll have to do FOIL, first, outside, inside, last. You know what I'm talking about on this one? All right, so this one you cannot just do 2 squared and a squared. That's only if it's a times problem, not an add problem. If it's an add problem, you have to break it up into parts like this. You always go back to what does it mean? 2 plus a squared means 2 plus a times 2 plus a. And you knew how to do FOIL to do that. First, 2 times 2 is 4. Outside, 2a. Inside, plus 2a. Lasts, plus a squared. Final answer, a squared plus 4a plus 4. You see how if I had done 2 squared is 4 and a squared is a squared, I'd have had the 4 and I'd have had the a squared, but I wouldn't have had the middle term like I should have. All right, so powers are important. Here's the last one, product of a quotient. Bottom line is you can just do a to the m over b to the m. You just put both of the numbers to that power and you don't flip it or anything. All right, so this one, it'd be 9 over 16. See what I did there? You just square the 3 and you square the 4. This one is a negative. It's kind of sneaky. How about if we ignore the negative for a second, just square both of them, 4 over 25, and then what does that negative mean again? Flip it. Yes, it means 1 over it. But when I have a negative exponent, I flip this over. If I had put 1 over all of this, it would do the same thing. It would flip it. So instead of 4/25, I will have 25 over 4 as my final answer. That's what that extra negative does up there, is it makes you flip whatever you had for an answer or put 1 over it. So this one, ignore the negative for a second, and it's just to the first power, 10 over 11. Now remember that it is negative and flip it, 11 over 10. Final answer. Did you get that? All right. So this one is a typical problem that we have to learn how to do here. Everybody get to this slide. Sorry, you don't have to write it down. You just find the right slide. All right, so do you get that if I had 2 squared equals 2 to the x, you need to get this first, that would mean that the x would have to be 2? Because they're identical. 2 to the second would have to be 2 to the what? Well, it's saying basically that and that have to be the same, right? All right, so if I could rewrite this problem right here as a 1/4, could really be written as 4 to the what? -1. Then I could say this is 4 to the -1 equals 4 to the x. And now the bases are the same. I'm going to train you to do this. If the bases are the same, just cancel them. And then the answer is -1 equals x. And so what does x have to be? -1. So get them to be the same base, and once you've got them to be the same base, cancel those bases, and then your answer will be that the exponents have to be equal. All right, so then if this is really true, I can stick in a -1 here, and it should be right. Is 4 to the -1 actually equal to 1/4? Yes, it is, so it worked. All right, I'd like you to try this one. This is going to take a stretch. Some of you will not be able to handle it, but some of you will figure it out. You want to get them so they're the same base. There's 2 ways you could do it. You could either say 1/2 to the x equals, I have to rewrite 64 as 1/2 to the something. Get it? Then they'll have the same base. But 64 is 1/2 to the, well, I have to get it to flip, and I have to get 2 to grow into a 64. Do you get that 2 to the 6th would be 64? Does that seem about right to you? It's actually the 6th. So then you go 2 to the, it's just not just 1/2 to the 6th. I'd have to get it to flip then also. Be the -6th. Now that I've done that, do you see that the answer is done and I just have x is -6? All right, now if I'm really right, if x is supposed to be -6, then I should be able to put it back in here and see if it's really true. So then I could double check myself and say, okay, 2 to the 6th, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Yeah, it worked. It was 6 times. All right, and then the negative makes it flip, and then it'll be positive 64. It's right. All right. Now there's there's another way to do this. Some kids like to put everything to a simple base. Do you get, I could rewrite 1/2 as 2 to the -1. Then that's still to the x power. Try to absorb what I just did there. I just rewrote this as 2 to the -1. Then I'm going to rewrite the 64 as 2 to the, what did we figure that one was? 6th. Then the bases cancel. Do you get that negative x has to equal 6? If negative x equals 6, then x would equal -6. Either way, the answer is -6. 2 different ways to do that one. All right, would you turn to this one, please? If you were going to solve this one, one of the important rules is that you need to get rid of everything except the exponential. So that 5 on the outside there, that 5 on the outside, you should be dividing by that on both sides. And I know you probably don't know what 135 divided by 5 is without a calculator, but somebody will do it. What is it? 27? Okay, thank you. So, 3 to the x equals 27. What you should have started with was this, and then 3 to the x equals 27. So now, if you can just rewrite 27 as 3 to the something, you'll pretty much be done. And what is 27? Yeah, so 3 to the x equals 3 to the third. Why'd we do that? The bases can cancel. Final answer? X equals 3. Did you follow that? All right, that's the hardest stuff for today. All right. Tomorrow, we're going to get into this kind of hardcore, all kinds of stuff happening at once kind of problem. But that's just like a sneak preview. And I'm going to show you, just for those of you that like to be ahead, here's how you do it. First, remember how I said I don't want to deal with this until later? Act like I just square everything, and that's a really good idea. Okay, if I just square everything in here, then I can flip it later. I'll deal with that negative sign later. All right. And then, do you remember the deal about if you have something to a negative power, that you can actually put it to the opposite side of the fraction and make it positive? Maybe you didn't know that, but it's true. I can bring these down here and make them positive a to the third. So I'm going to rewrite this as 4, and my b to the fifth was happy where it was, so I leave it alone, over 5, and none of these are happy down here, so I got to move them to the other side. And this will be 4, and then the a to the fourth goes on the top, and the b to the second, this one here, goes to the top. And then on the bottom, I will have, this guy is moving downstairs, so that will go down there. A to the third. Now they're all positive exponents. Then I can do some canceling. This is b to the seventh on top, and there's an a to the fourth on the top, and an a to the third on the bottom. And then this will cancel this, so I have 4b to the fifth. B to the seventh. Over, and then the a to the third on the bottom, and the a to the second on the top. There's an a on the bottom, you're right, good. So there it is, and I got to do that to the negative 2 power. And then I ignore the negative for now, and I square everything. 16, b to the 7 times 2 is 14th, over 5, so it's 25a squared. And then I got to remember that I actually never handled that negative up there, so now I just flip the whole thing. And it ends up being 25a squared over 16b to the 14th. Those of you that learn fast probably already processed that, and it's not that hard. The weirdest thing was the stuff that was negative exponents. Those are not happy where they are. You move them to the opposite side. This wasn't happy where it was. Move it up here and make it positive exponent. That's not happy. Move it up there. Make it a positive exponent. All right. That's what we'll do tomorrow. And now you're sort of just had a taste of it. But for today's homework, I'll start it with you. Would you please find this worksheet right here? It's your homework. There's only one of them today. Let's do the first couple problems together. This is 5.2, page 248. This is actually out of your book, but we obviously haven't handed out those books yet this year, but we won't. But these are typical questions about exponents. So what is 5 to the negative third? I tried to teach you to ignore the negative to start with, and what's 5 to the third? 125. And then what does that negative really do to it? It makes it 1 over it. It flips it. There's your answer. All right. This one, when there's a negative in the front like that that's not in parentheses, then you wait till the end to make your answer negative. So it's just plain 6 squared, which is 36, and then you make the negative happen, negative 36. I know some people think, wait a minute, isn't that supposed to be negative 6 times negative 6? Nope. Not unless it's in parentheses. Like this one's in parentheses. So that means negative 12 times negative 12, and then we'll flip it because it's got the negative there. Negative 12 times negative 12 is positive 144, and then I'm going to have to flip it because of this negative right there. So it's 1 over 144. All right, so I just want to give you a little help on some of the easy ones. Now let's go to one of the harder ones and I'll help you with that. I think a lot of these are easy until you get to that part. Number 4, part A, get there. Do this one with me. You in the right spot? Get to the right spot. All right. Do you get that if I could make these both be 3 to the something, that then the bases would cancel? So, what's 1/9? 3 to the what? Negative what? 2. And now my bases can cancel, and what's the answer? X equals -2. All right, this one. It's giving you a hint by giving you 5/3 here. It's saying, why don't you write this one as 5/3 to the something power? Well, to get 5/3 to be this, I'd have to square the numbers, because then I'd have 20, no, not square, cube the numbers. Because I do 5 cubed would be 125, 3 cubed would be 27. Now I got the right numbers if I cube it. And then what do I have to do? Make it flip. So what's the final answer? -3 up there. And now they have the same base, so you can cancel them, and now you'll have the answer. All right. There's a few in here that you're going to have to think through yourself. And that's your homework for today.